This is lab report one, charged tapes. And so introduction, so tapes involved in the experiment were found to be positively charged. And then some repulsion occurred when the two tapes were put next to each other. And then this was the charged tape that was calculated, and then also the deficiency of electrons for tape that was calculated as well. And so the purpose of this lab was utilizing principles such as the electric force or Coulomb's law to analyze how charged tapes interact with each other and with other objects that are also charged or they're electrically neutral, and then modeling the interactions of the two charged particles in GlowScript with assumptions. So that was the coding portion. Fundamental principles of this lab. So Newton's second law, Coulomb's law, and then Newton's third law. Newton's law, second law, was found to determine the magnitude of the gravitational force. And then Coulomb's law was used to determine the charges of the tapes. And then Newton's third law was used to relate the electric force to the gravitational force. So they would have equal magnitudes. So the initial conditions, so that this was the tape length, which was 0.21 meters. Using the tape length that was used to find the mass, which was this value in kilograms, and then the width was about almost 0.02 meters, which was just found from the packaging of the tape. And then the tapes are neutrally charged before the experiment started. As for the system, that was the tape, table, pen, and books. The books were used in the portion where the tape A would act on tape B, and then the surroundings was the physics classroom, which is where the experiment was conducted. And so from the experiment, these were the observations. So first, when the tape was charged, it was attracted to the hand. And then after that, the charged tape was slightly attracted to a neutral object, which was the table. And then after adding charge to a pen, that was attracted to the tape. So they were oppositely charged. And then for the main part of the experiment, tape B rose slightly as a result of the force in tape A. So this is what it looked like. This you can see from the lab instructions, but this was exaggerated. It was exaggerated because it actually only rose 3 centimeters in real life. And then after that, the magnitude of gravitational force was calculated, which was its value. And that was just the same magnitude as the electric force based on Newton's third law. Using after knowing the electric force, that was used to find the charge, which was then also used to determine the number of atoms in the tape. And then that value was also used to find how many atoms there were per electron. And this was all experimental data and calculated values based on the results. So the coding portion. So these are the assumptions. So air resistance was not considered the calculation because it was conducted in a physics lab. And then each tape was assumed to act as a point charge. And then also each tape had the same amount of charge, which was evenly distributed along the length of the tape. This was the code. So these were the constants, and these all came from the experiment, except for the scale factor. The scale factor was needed for the model. And then these were the calculations. So again, these were all the same calculations that were done in the experiment. And then the main difference from the code to the experiment was really the modeling portion. So this was tape A and tape B, and then they both had the same charge. And then of course we had to have an R vector to be able to find where to put the arrows that would represent each force, which was on tape B. And so this was the results from the code. So this is the model. This was the force in tape A, which is the electric force, and this is the gravitational force that was acting on tape B. And then these were the results of the calculations, which match from the ones from the experiment. And so for the what if and why, and so for the most part, the observed interactions would remain unchanged. And that's when you change the convention from that would be electrons that are now positively charged and protons that are negatively charged. So in physics and fundamental principles, this would remain unchanged. That only changes the convention and how we observe each type of particle. And then for the why, it's important to handle charged tapes as little as possible to ensure the electrons don't rub off prematurely, since this was an induced charge by during the experiment, so it's not going to be permanent. And as for the sources of error, so during the experiment, the tape often made significant contact with the hand. The tape definitely lost electrons because of this interaction. And then as for the other source of error, there were multiple assumptions, which made it so that the situation doesn't really fully reflect real world conditions. But in conclusion, in real life scenarios, there will usually be some type of interaction between objects. And so charged objects, whether they're positive or negative, that doesn't really matter in this instance. They will slightly attract neutral objects, which is polarization. And then Newton's laws still apply in interactions that involve non-mechanical forces. So thank you for watching.